have some problem with my sales. Why it didn't increase since last month? It even tend to decrease.
Have you seen your product is customer rate? I think you need to take a quick review from your customer.
It's wasting time, isn't it? I need to arrange my no, I need to arrange the procurement material for my production every day to stay it profitable.
I have heard same issue from my friend, but now he can do it all more easily. You can try Tokolitik apps. You can get analysis from your product review. Also, you can predict your sales for next 6 months and even predict how much material procurement for next month.
Wow, that's cheating. I can make a decision in no time with that service.
Hello, my name is Hartan Bari Mulyadi. I am from Cloud Computing Learning Path.
Hello, my name is Fahrul from Machine Learning Path.
Hello, my name is Fitriani Nasir from Machine Learning Path.
Hello, my name is Ronald from Android.
Hello, my name is Randy Yuanda from Android Learning Pad.
Hello, my name is Ibe from Cloud Computing.
To be able to grow properly, IKM and UMKM need to observe market condition and needs. Market adjustments are needed by delivering product to right customer. For example, how to improve our services as a seller to respond to customer feedback and optimize our production.
There is 65 million estimates UMKM in Indonesia. UMKM also contribute 60.3% to national economy. Around 30% of UMKM are a potential market for Tokolitik. The main problem is most of UMKM still lack of knowledge to serve products based on market needs. They also lack of ability in analyzing market needs.
Tokolitik is able to solve all these problems. Our services is able to provide quick decision, help business to grow, and are time effective to handle tedious analytical work. Tokolitik is a mobile app that applies machine learning and modern cloud architecture to be solution for IKM and UKM.
We use web scraping technology to be able to get datasets from Tokopedia product reviews, and we also did labeling for each data. You can access the dataset from the right-hand URL.
In order to use Tokolitik feature, user need to fill several fields for their products. While to use self-prediction feature, user need to fill transaction records for several months. Then Tokolitik will provide you the prediction for the next 6 months.
Every request that comes from Android app will be sent to Compute Engine by HTTP request. Then it will be handled by Web API. If user want to analyze product review, instead will request the Cloud SQL for Tokopedia product URL, and then system will start web scraping. The instance also requests cloud storage to load and run model by using data from scraping result and then send it to client in JSON.
Pre-processing process on feature review analysis. Processing is carried out by cleaning up non-alphabet character, using values and duplicates. And because the dataset is NLP, we have to change the format string to numerical values. We decide to use the tokenizer technique. Tokenization is the process to split string become word or token, then from token to data numbers. First version for feature review analysis. Here is the model summary. For the input, use embedding, next use LSTM and one hidden layer, and then the last layer for output. And can be seen in the plot that when training, the accuracy and loss are quite good, but the validation loss is still overfitting. Now we try to improve the previous version. Here we do. First, look at the dataset. It was unbalanced for the positive class. So we try to balance the dataset using undersampling. So we have around 1900 data with balanced class. Second, because in previous training was overfit, we use dropout layer to minimize overlearn while training. Third, make a misleading dictionary or typo word dictionary for better at the training process. So we have the same meaning word represented as just one word. Here is the model summary for version 2. The model we simplified with LSTM and dropout layer. and then train it with a more clean and balanced dataset. Can be seen in the plot that when training, the accuracy and lasting good, but validation loss is still overfit, but it's better than the previous version. It's still overfit because we use a small number of data. We just use around 1,800 balanced data set. Possible improvement, we need more data set, better data set creation.
For sales analytics, Compute Engine will get transaction history from Cloud SQL and perform training model inside Compute Engine, and then return result as JSON as well as the charged image.
In our transaction prediction feature, the model has been built with time series approach using bidirectional multi-step LSTM. Bidirectional means that LSTM and our hidden layers will learn the input sequences both forward, past to future, and backwards, future to past. Bidirectional LSTM is effectively increase the amount of information available to the network, improving the context available to the algorithm. Here, we are using RMSE or root mean square error for measure our model error. RMSE is a frequently used measure of the differences between predicted values by a model or an estimator and the values observed. As we can see, in the model summary, we have 4 layers consist of the first layer is our bidirectional LSTM with 200 units. The second layer is unidirectional LSTM with 100 units. And the third layer is dense layer with 50 units. And the last layer is dense one with 6 units. Here we set 6 at the last layer because it's number of our expected output. Dense layer is the regular deeply connected neural network layer, and dense implements the operation of activation between input, kernel, and bias. Activation is the element-wise activation function passed as the activation argument, and kernel is a weights matrix created by the layer, while bias is a bias factor created by the layer. These are all attributes of the dense. Here we have provided last 10 epochs detail to show our loss and RMSE in our model. And as you can see, we use 300 epochs and the loss and RMSE are getting smaller towards the end of epochs. The loss in the last line shows a very small value, 0.0057, and our RMSE is 0.1 in amount of time about 20 milliseconds per step. Here is the graph of comparison between actual data and predicted result to test the last 6 month data in our dataset. So July 2020 until December 2020 is the last 6 months data in our dataset for product ID 1, for example. The closer the actual line and the predicted line, the better the resulting model we have. And as you can see, this is the graph of our loss and RMSE history. The lens shows us that loss and RMSE are getting smaller within 0 up to 300 epochs.
Here how to clone our project. You can see our repo. For the backend service, there's two ways to deploy. First by using GitHub clone and the second by using Docker.
Here are our future plan goals. We will commit to try our best to fulfill it.